Thank you, Paul. If you were an astronaut chilling on the International Space Station and you would look back to Earth, what would you see? You would see two main structures that are made by living things. The Great Wall of China, built by millions of people, and the Great Barrier Reef, made by billions of tiny organisms, those little coral polyps. Coral polyps are continuously building limestone houses on top of one another, expanding like a city and forming the reef ecosystem. But what is a coral polyp? Let's look closer. A coral polyp looks like a bag, basically. A small bag, a very small bag, typically no bigger than a grain of rice. It has a single opening, the mouth, that is surrounded by a crown of tentacles, and a base on which it sits. And it is at its base that each polyp is continuously building a small skeleton, its little house. And it is the combined forces of billions of those tiny guys that has created, over the last millennia, this unique edifice that is the Great Barrier Reef. Very recently, though, Australian scientists have shown that coral growth on the Great Barrier Reef is dangerously declining. The main suspect behind this decline is most likely a phenomenon that has just recently gained attention. It is called ocean acidification. The burning of fossil fuels during the last centuries and since the Industrial Revolution has dramatically increased the quantity of carbon dioxide released in the atmosphere. You can see it on this graph. We've all heard about greenhouse effect, global warming, but did you know actually that half of this carbon dioxide is being absorbed by the oceans, making them more acidic, and this is what we call ocean acidification. Ocean acidification means trouble for corals, and this for two main reasons. First, acid dissolves limestone. So just as you can dissolve a limescale buildup in your kettle with a simple acid, just like vinegar, ocean acidification will dissolve coral skeleton. And second, the building blocks that those tiny polyps are actually extracting from the surrounding seawater are becoming more scarce in this new environment. So in other words, not only coral reef will have to fight to keep their skeleton, their existing skeleton intact, but they will have to put more effort into finding those building blocks to make their skeleton and to make new houses. Baby corals are yet more at risk, and this is because they are born without a skeleton. They need to find the energy as well as the building blocks to make their skeleton from scratch. So our questions were, how is coral growth affected by ocean acidification? How does it work? Are corals going to be able to cope or adapt to this new environment? Even though those questions have vast implications, have big implications for vast reef systems, such as the Great Barrier Reef, the answer can actually be found at a very small scale, the molecular level. Over the past 30 years, a scientific revolution has been taking place in biology. We now have the ability to go to the very elements of life, the DNA, and to basically directly read the genetic code to understand what's happening. In my research, I have applied this new ability to understand how corals build their skeleton and how it is affected by ocean acidification. For this, I raised baby corals in today's seawater and in seawater, acidified seawater that is expected in the next 100 years. We compared how their genes differ between these two conditions. Results are pretty complex, but one thing is clear. Corals stop investing energy into growth when the water around them becomes more acidic. And actually, if you look at those two photographs, you can see that it also has an effect on the end product, that is the coral skeleton. As you can imagine, this may have major consequences for the survival of baby corals and their growth into the beautiful reefs that we know. But most importantly, this may have dramatic consequences for Earth. Millions of people around the world depend on coral reefs for fishing, tourism, coastal protection. If corals struggle to build their skeleton, it's the entire reef ecosystem that may collapse, creating food shortages and economic breakdown. Now, I don't want to end this talk on such a gloomy picture. I want to tell you that there is hope. Latest research has shown that coral reef might be able to adapt, to some extent at least, to ocean acidification. And this is very good news, because on the scale of decades, ocean acidification cannot be stopped just like that. There is a huge momentum in the atmospheric ocean system. Therefore, what we need to do urgently is reduce as much as possible all the other stressors that are actually threatening coral reefs, because their combined effect, together with ocean acidification, will make the difference between functional reefs that support fishing, tourism, and provide coastal protection, and dysfunctional reefs, where those ecosystem services are lost. Thank you.